Well, I guess I'll begin. Good afternoon, everybody. My name is Jonathan Witt. I am a project specialist in the outdoor education department, titled Project Specialist, Environmental Outdoor Education. And I'm coming to you live from Science Outreach's virtual learning space. And this is just a really great space to really fulfill our mission and conduct what we've been doing really for many, many years. So just want to give just a quick kind of background, really short snapshot of, again, science outreach and what this resource is at the San Diego County Office of Education. So let me just do a quick screen share. And here we go. So really for over 25 years, we've provided hands-on learning opportunities that really bring science to life for students throughout San Diego County. And that was it, hands-on, literally on-site activities. So definitely in a virtual world, it's a little bit different, but that's the transition that we've had to make. But really our goals, again, have been to provide those programs with interactive activities. We want to ignite that scientific awareness and literacy so they can become that next generation of science and technology leaders. And again, incorporate experiences that just create hands-on learning that's truly meaningful and enriching and maybe has a sense of place, a sense of purpose for those participating students anywhere they're in the county. So really those programs are modeled on, small group learning. So you can see, we want an instructor to student ratio of really no more than one of our educators to 10 students. So that's why we'll provide multiple educators when we do an on-site program. They're all inquiry-based. They're all student-led and educator-facilitated activities. I really, impress upon my educators that, again, they are guiding the students through these activities. The students are really doing it. That is, what the focus of any of the activities that they're doing is. The students are getting hands-on experience. They're utilizing microscopes. They're conducting water quality testing. And again, we're able to cover just a broad spectrum of scientific concepts and disciplines. But in spring 2020, we got the approval to create this virtual learning space. So again, it's just been a nice alternative to now be able to replicate those same on-site experiences within a virtual format. And we do hope that in the near future we'll be able to provide both, get back to being able to provide the on-site version of the Splash Science Lab and also still have this virtual format available as well. So you can see that's kind of where I'm at right now. That's one of our educators, Cyrus, and just the equipment and the resources that we have within this learning space to really do our best to provide an engaging and enriching experience. So that's really what I wanted to highlight a little bit, is really our flagship program, which has been around since the beginning for well over 25 years, and that is our Splash Science Lab. And it's just an amazing program. It really, again, focuses on place, focuses on community, and focuses on environmental impact, particularly environmental impact that is caused by us, by humans, the activities that we do and the impact that it has on all of the living things and even non-living things. So Splash Science Lab, right? Really the focus is that, learning about this concept of watershed science. Well, really, again, what does that mean? A watershed is an area of land that drains all of the water that falls on it or flows through it to a common outlet, such as a large river, lake, bay, or ocean. So again, we can think about that as anywhere we are on planet Earth. If we're on land, we're not on the ocean, but we're on land, we are within a watershed. Right? And again, we want to think of that geographically bounded area. So maybe mountain ridges are going to be borders between two different watersheds and have those headwaters, the beginning part, right? Where all of those little streams and creeks and rivers are starting to flow down the mountain. They're getting larger, they're getting longer. And again, maybe they're emptying out, like I said, to a lake, to a larger river, potentially, they could end up in the ocean. So here's a quick snapshot at San Diego County, right? All of the areas in color are the 11 watersheds that empty into the Pacific Ocean. And you can see they're all different shapes and sizes. Some are long, some are large, some are round, right? Some have a large outlet area. Like look at Carlsbad. Look how long that part of the coastline is. And look where the inland portion is compared to San Luis Rey, which has a small outlet point, but much broader area as we move inland. The gray area, which is still part of San Diego County, are watersheds that empty into other places that are not the Pacific Ocean. So it could be the Salton Sea, could be tributaries of the Colorado River, and maybe eventually leading out to the Gulf of California. All right, so one of the activities that we focus on, because we're talking about watershed science, we're going to be talking about water quality. Well, really, what is water quality? I mean, water quality is how we really can define water for a specific use. We're going to look at chemical, physical, other biological factors within a sample of water, based on, are we going to use it for drinking? Are we going to use it for washing? Are we using it for recreation? Or are we looking at it through the lens of just a sustainable ecosystem for all the plants and animals that might be there? So one of the things that we've had to kind of translate, again, in this virtual setting is really take the same resources that we would bring on site with us and have the students utilize, which is a wonderful resource. These great worksheets. We have a data sheet. We have procedure cards. So we've just had to then bring that here into the virtual learning space and conduct those activities with the students. But again, imagine to that one image where you saw the kids around that table, they would have these same resources. So the first thing I wanted to do, let's switch over. And you can see, I've got my water quality data sheet. So in that time with the students, we would go through 5 different physical factor tests. We would look at temperature. We would look at nitrates, explain what that is. Phosphates, these nutrients that might be found in water. pH, right? That scale of acids and bases, things like orange juice, battery acid. And of course, dissolved oxygen, the amount of oxygen that would be in the water. Critical things to understand and learn is, well, what is this ideal range? Like it says here, we want 14 to 27 degrees Celsius or 57 to 80 degrees Fahrenheit. Dissolved oxygen, we want 4 to 9 parts per million. All right, here's that it was upside down. So you can kind of see that. So those ideal ranges really tell a scientist, right, what seasonal changes might be happening, if there is pollution or any other environmental impact. Now, it doesn't mean that if any one of those is outside of its range, like that 4 to 9 parts per million of the dissolved oxygen is outside of that, it's necessarily a bad thing, but it could be presented itself as a red flag. And this is a really fun experiment. So I'm gonna do that for you right now. So you'll be able to see my water sample. And you can say, wow, it looks kind of yellow, right? Why does it look yellow? Well, it didn't come that way. But what I did and how the proper procedure for this test is I needed to add 3 different chemical solutions to basically fix. And what that means is it's going to lock in the amount of dissolved oxygen or the amount of oxygen that's in the water that would be available for organisms that have lungs, like fish, for example. So, because let's say maybe if I'm out at a test site, out at a lake, out at a river, I might have to wait a few minutes before I can actually perform this test. So by adding those 3 solutions, I could again fix, create a compound. Oh, there we go. All right. So you can see I've got that. Now my next step, what I need to do, because I need to find out now how much oxygen is in there. By doing that, I'm adding this solution called sodium thiosulfate. And really what that's going to do is it's going to match the oxygen molecules one by one with this solution. So I'm going to be doing something called a titration. So I actually have to add the solution to this test tube. Make sure I get out all the bubbles. All right. So you can see I've got my test tube. And by titration, that means I'm going to add it drop by drop. So it is a very slow, methodical process. But that's how we're going to get an accurate reading. Next step, I'm going to add something called starch, a starch indicator, right? And really all that's going to do is change the color. It's going to change it from this kind of yellow to purple. You can see that it's already experiencing a color change, and that's not going to do anything to the amount of oxygen. Again, it's just going to make it easier for me to see that color change. So the next step is I need to get it into my vial right here and add it into this. Fill it up to the 20 milliliter line. You can see got all these different numbers. I've got 5, 10. Fill it up to the 20 milliliter line. There we go. Put the cap on. This has a nice little hole that I can insert the syringe into. And then again, it's drop by drop. Drop, swirl, drop, swirl, drop, swirl, drop, swirl, drop. I'm starting to see a slight color change. Maybe you can see that as well. It's just getting a lighter purple. This is a really great visual for the kids. Kind of really fun, exciting science. So it looks like I'm almost there. Boom, clear. So as soon as I got to that immediate color change to clear, I'm going to stop the titration. I'm going to now remove. So I actually had 10 milliliters of that sodium thiosulfate. And basically what I need to do now is count. So I go from 0 to 10. I count how much I use. I'm going to go to this tip of this green part, and it says I'm at 5. So that means I used 5 milliliters of the sodium thiosulfate. And again, it's a 1-to-1 with the amount of oxygen. So then I would have 5 parts per million of dissolved oxygen in that water sample. Perfect. Exactly where I wanted to be. Remember, getting back to that ideal range, I needed to be between 4 and 9. But again, as a good scientist, I would want to do that test over time, multiple times, over multiple days, over weeks. Because again, I might see a seasonal trend, right? It might change from week to week, month to month. Maybe tomorrow it would be up at 9. Maybe the next day we back down to 4, right? Maybe later in the summer, it would be completely different or outside of that range. So that's the process of doing this repetitiveness, repetition, right? With all of these activities, with all of our science experiments. One of the other things that we do is we talk a bit again about predator-prey relationships, right? Because again, think about that context of the watershed, right? Anywhere we are on land, we're within a watershed. And even though we put on roads, we put farms, communities, houses, businesses, right? There still is natural land, right? Wilderness area. So we know where there's wilderness, and even when there's cities, we can always have wildlife. So we can do some comparative anatomy analysis with some animal skulls. Again, so we would break up the students, give them some worksheets, and let them see if they could establish predator-prey relationships. So you can see I've got 2 different skulls. So we want to find out things like, is this a carnivore? Is this a herbivore or an omnivore? Is this a predator or prey? and ultimately maybe what type of animal that is, because that's going to speak to, again, overall food chains and food webs and how many animals are within a given place. Let's say within an estuary, that point at the end of a watershed where that water, where those rivers and streams are emptying in that larger body of water. So I'm going to start off with this larger skull, and you can see I've got my identify the animal worksheet. And I'm just going to take down some information. So again, this is exactly what the kids would be doing with us. They would be following through this, either by them individually or with their partners. But first I want to look at orbits, right? Which are these eye sockets, right? Where the eye would be when it's alive. So my first question is, I need to find out or determine the relative size. I'm going to say that's a pretty good size eye socket, which would lead to say that's a pretty good, going to be a good size eye, a very large eye. So the eye socket, relative size of the skull, it's going to be large. But we would let the students choose whatever word they think is best, right? Large, small, medium. Placement on the skull. Where the eyes be, would they be forward facing or side facing? To me, it appears that if I'm imagining, again, this to be alive, that eye is going to be going out, facing forward, instead of facing the side. Nasal passage. Now, again, we want more than just the nose, or where the nose would be. We want this whole area right here, where all of those olfactory senses are. I would say it's relatively small compared to the rest of the skull, right? It doesn't appear that it has a long snout, right? It doesn't have the bone structure to support it. And there probably isn't a lot of loose flesh. So I would say it's relatively small. Incisors. All right, so we're going to look at three different teeth. Well, actually, groups of teeth, I should say. So we're going to look at the incisors, which are the teeth right here. And you can see it's actually missing a few. And that shows us that this was actually a field find, something we found out in an estuary. So of course, maybe it lost some teeth. But I can count on this one, maybe about, let's see, 1, 2, 3, 4, 5, maybe missing one. So it has about 6 teeth. I would say that they're small, somewhat sharp. So again, yes, it does have incisors. They're going to be small. I would say that's a good number, and that they're pointed. Now I'm going to go again to the canines, which are these teeth. So again, you can see missing one on one side, but there is evidence that it did have a canine tooth there. So one here, one there, and 2 on the other side. So yes, they are present. They are relatively large. Very few, again, only 2, and they are pointed. I'm going to look at the molars, right? These ones on the back. Quite a few molars, particularly on the bottom portion. Large, very pointed. So again, yes, large, many, and pointed. Okay, so now my next step is, well, I can just make a guess, right? I can make a great educated guess if I felt like it. But there is information, right? There are resources out there that a scientist can utilize, right? That can help them determine, almost like kind of like a dichotomous key. So I can identify the animal guide, and it's going to give me information on maybe the characteristics of a carnivore, characteristics of a herbivore, indicators of a nasal passage. So let me look at nasal passage, small. A long nasal passage in relation to the skull, so a long or large one, indicates the animal has a good sense of smell. Felines, so cats, have smaller, shorter ones. Canines, dog species, have longer, larger ones. So it's probably some type of cat, maybe some type of wild cat. Characteristics of a carnivore. Small, few incisors. Okay, that kind of matches up. Forward-facing eyes. I did decide it looked like it had forward-facing eyes. Well-developed and sharp pointed canine teeth. It definitely had that. So I'm going to say this is probably a carnivore. So I've got to go back to the worksheet, got to complete that. Again, at the bottom, I've got my species classifications. I've got the options down here. Carnivore, omnivore, which would be, it eats both plants and animals. Herbivore, predator, prey. I'm going to go, it's a carnivore and probably a predator. But what is this animal? Well, now I have to jump to another worksheet and say, well, these are all estuary animals that we can find in Southern California. We've got rabbits, bobcats, red-tailed hawks, all sorts of different species. So again, based off of what I was examining, I was like, well, it doesn't look quite like that one. That one's got too long of a snout. Anyone's over here that look like a decent match? I'm kind of going to go with a bobcat. And it shows that it's carnivore, all right? And it's a predator, but it's also a prey. And I only put down as a predator. So that's the interesting thing. Because we think about this, well, how big is a bobcat? Is it the biggest, is it the largest animal, let's say, within that ecosystem, within that habitat? Maybe not. It might be, but it might have predators. It might have mountain lions in the area, which would definitely be a predator of that animal. It might also have coyotes, right? Wolves, depending on where we are in the world. And again, the ecosystem dynamics, what other animals are there. It might be that top predator. It might be somewhere in the middle. But that's going to be a good indication too of that balance within that ecosystem. And if we were to again compare it, look at this little guy, right? Very, very different skeletal structure, right? Quickly, right, we can see it has molars. It's got two very, very pointed incisors. No canines. Look at that gap right there. There is nothing there in the middle. Very good sense of smell, right? As we determine with that long nasal passage. And look at the eyes, right? That's straight on. So imagine the eyes are probably facing out to the side. So why would those characteristics, particularly the eyes and the good sense of smell, be advantageous for that animal's survival? Well, think about this. Based off of the information that I read, this is definitely not a predator. This is a prey. And this is a herbivore, because herbivores do not really need those big canines, right? They're not ripping off chunks of meat. They're not eating flesh from other animals. They just need strong molars to grind down the grains, the grasses that they're eating. And those incisors, sharp incisors, are really used like scissors. The eyes to the side, because they're prey, that's going to help them see better. Imagine almost having vision towards the back. So if they're grazing on the grasses, and there's a bobcat coming in from behind, they have a better chance for survival. So again, this rabbit, a good prey animal for a bobcat, is going to need to utilize that great sense of smell and those side-facing eyes. Well, that gives you, again, just a quick snapshot of our Splash Science Lab. Now, that is actually one of 5 programs that we offer. We also offer our Green Machine Lab, which is really focused on sustainable food production and knowing, what soil science is, why we need to have healthy soils to maintain areas for positive and sustainable food production. We also have a program called Geology Rocks, which is just that. We're going to be learning about rocks, minerals, things like volcanoes and earthquakes, and those unique geological phenomenon that happen across the globe. We also have a program called Crazy Kelp Forest Lab, and we're learning about a unique and special ecosystem that's found almost exclusively off the California coast, and that is the giant kelp forest. So this amazing plant organism that lives down one of the fastest growing plants on the planet. It can grow up to about 2 feet in a day. And we're going to be learning about that and how it really then becomes a unique forest, a habitat for other animals, things like sea urchins and sea stars. And again, talking about that balance of life and how things are going to work together. Last one is one of my favorites. It's called Curious Cephalopods. Whoa, what is that? Well, cephalopods are squid, octopus, and two others that are a little more less common, nautilus and cuttlefish. These are amazing, amazing animals that have very specialized and unique adaptations. Things like oh, looks like there's a question. Where do we go if we are interested in having a science lab? Well, you can definitely check out our website. Go to sdcoe.net under /outdoor ed, and you'll see the listings for science outreach and all those 5 programs. It'll give you information on how to book. It'll have my contact information, my program assistants, and there's a booking request form. And basically what you would do with that is you can then select the program that you're interested in. We ask you to provide 3 potential dates that would work with you, and then we would look at our master schedule. I can definitely give you my information is it's jonathan.witt, so jonathan.witt@sdcoe.net. Anybody's welcome to reach out to me directly, and I can provide that information for you or answer any questions about how we can make this possible. And like I said, right now, we're in the virtual world, we're in the virtual format, but we do hope that in the near future, we'll be able to get back out to sites and really doing what we had been doing for well over 25 years. So just, again, a great resource, an exciting opportunity for the students to really be engaged in science in a unique way. And I think the value of the science outreach is because, again, it is in an informal setting. We have the flexibility when we're on site to be outdoors, be inside in a classroom, wherever that physical space is that we are, we utilize it and take advantage of it and connect it back to the resources that we have and the programs that we do. Oh, there's one great question. Yes, we definitely are looking to build capacity with these programs and actually, teach the teachers. First and foremost, our educators go out to the sites. Our educators are in here. So we're doing that full instruction. But these are lessons that can easily be replicated. These resources can easily be shared with on-site educators. And we are most happy to support you in that professional development and get you to be able to do not just these programs, but really get that baseline understanding of how to facilitate an informal science program with students from kindergarten all the way up through high school. And I believe my time's up. So again, thank you so much for joining, and I hope this information was very helpful. And please feel free to reach out to me.